Hi everyone, thanks for joining. As KCD Munich was mentioned, we have sticker here for KCD Munich, so to make sure that you're attending next year again. Yeah, welcome to our talk. Let's start with a small introduction and over to Phil.
Hi, good morning. Good that you survived yesterday. I'm glad that everybody's here. And yeah, I'm Philip. I'm at White Duck, as Tim said. I'm a senior Kubernetes DevOps engineer. My daily business is around Kubernetes, for sure, and automation, Terraform, stuff like this, and especially on Azure. Bless you. And with me I have Nico.
My name is Nico Meisenzahl. I'm Cloud Solution Architect at White Duck, basically helping our customers to get their cloud native workload running mainly on Azure. Yeah, so today we would like to talk a little bit about container Kubernetes security, and but before we start, so maybe do we need to talk about security? So this is basically a report from Red Hat from last year, so basically the data from 2 years ago, so thanks to Red Hat for that one. And if you check out, so basically we have pretty high numbers for detected misconfiguration, also major vulnerabilities to remediate, and then we're going with security incidents during runtime. So it looks like we still need to talk about security or at least implement security in our environments. So going further, they're doing that every year. So this is the report from this year based on the last 12 months, and which is really, really strange for me is the first one. So basically, security incident during runtime is going up since last year. So really, it looks like we need to invest into runtime. Detecting misconfiguration is going down, which is really nice. Still, major vulnerabilities to remediate are also pretty high as well. So it looks like we still need to talk about security. This is why we're here today. Basically, it can be quite simple. So I'm not sure if you attended last year's ContainerDays. I talked in this room about hijacking Kubernetes and basically showed how easy it can be if everything goes wrong. So if you like to want to make sure that you should think about security, check out this talk. It's on YouTube. All the demos are available. So it's really, really easy if you don't think about security at all. But how to start with security? So I'm a big fan from implementing quick wins and then iterate on it like you do with all the DevOps stuff. So really starting with the quick wins, then iterate, implementing further things. It's much better than, let's say, doing a security project, talking 2 years about, yeah, let's implement security, but basically not doing anything. Of course, it's good to have those projects, but starting small, iterating really helps to get started. Things to think about is, of course, rising awareness, shifting left, basically thinking about security not 2 minutes before releasing it, maybe a little bit earlier. Also, talking about container Kubernetes is also the application which needs to be secure, the deployment code, container images, and then if you go to Kubernetes, we have policies, we have network policies, and many, many more. But this is not what we would like to talk about today. The main idea today is to focus on 3 open source tools. First is Wolfi, Wolfi OS, which can help you to build secure images. Then Phil will talk about Cosign and validate our images to make sure that basically the image we are deploying are the images we are building. And then we will round up with some container runtime security and Tetragon. So this is basically the main focus for today. So starting with Wolfi. Not sure, does anybody used to Wolfi from Django so far? Hands up, anybody? Nobody. Okay, perfect. So basically, the idea of Wolfi is to build a so-called undistro Linux-based image. So what does undistro mean? So maybe somebody of you knows distroless from Google. So it's basically the second iteration. Also, many of the folks from Google joined Django so far and started building the next iteration of distroless. So really building a Linux which is designed to run and securely run containerized workloads. So it's really a small kernel, only the things you need to run containerized workload, and this doing securely. And the really nice parts of Wolfi is that it's not only this small Linux, but also a whole ecosystem surrounded by it. So you have packages, you can build your own packages. It's based on APK, you know from Alpine. You can opt in, if you like, to get a full declarative and reproducible build system. So they have tooling around it to really build your container images, and I will show you in a sec. And all the images you build getting SBOM for all default packages out of the box. So basically, you really know what's in your container images. You really know all your dependencies. Talking about SBOM quickly, so software bill of materials, it's basically the list of ingredients of your container image or your application. And not only your dependencies, but also any hierarchical multi-level dependency. So basically dependency of your library, of the dependency of the library, the dependency, and so on. Which is sometimes really hard to get all the details, what you really have in your application or linked to your application. And this is where SBOM helps. So without you basically do not know which dependencies you have, you don't know if there are any vulnerabilities, which version you're using, and so on. So basically, SBOM is the baseline for us to implement any kind of vulnerability scanning, security baseline on our container images. And Wolfi provides us with those out of the box, which is really nice. So, shifting over to a demo. So we will start with just a Docker file, as you know, normal image, and then we will try to get this up with Wolfi as base image, and then have a look at two tools, Melange and Epico, which helps you to build declarative and reproducible container images. Everything we do, you will find on the repo and GitHub from us, so we'll share the link later and also added some details here. So, I created a small Hello World application, doesn't matter at all. It's node related, so it's just a basic Docker file, nothing specific here. So this is basically the baseline we were starting with. Just to make sure that everything is running, let's build that one. So I'm using ContainerD with nerdctl, but it's basically the same. You can just skip nerdctl, go with Docker. It's basically the same here. So building this application quickly and spinning it up. And we now should see at least, yeah, okay, it's listening on. We could now open the browser. It's basically hello world. Doesn't matter. So this is basically, I guess, everything we all know, we all do. So how can we now get to Wolfi or to a more secure image? And to do so, we're first starting with checking out our vulnerabilities. So first thing I'm doing is basically quickly exporting our image we have just built to a tar file. It's optional. So with Docker, you can directly continue. With nerdctl, you have to export it. And then using a tool called Sift, which allows you to build an SBOM based on the container image. It's not yet Wolfi, so we do not have SBOM in place. So we have to build one. Quickly executing that one. It's basically to include all layers, define the output parameters, the tar file, and then basically piping everything into the SBOM JSON. So now the image gets parsed, and we have 1,106 packages in here. And now if you go to the SBOM JSON here, we have a long, long list of our dependencies in our container image. Those are dependencies from the base image, as well as our application, of course. So next is to analyze that one. And there's a different tool, which is called Gripe. You can just bring in the JSON here, let it run. It will update its database. Oh, there's a newer version available. And basically lists up all of dependencies. And then also includes, if those are fixed, includes the CVE, and also if it's a high issue or not. And you see it's a really, really long list for an application with basically the default node image with a long, long list of vulnerabilities. So let's focus on the base image here. So let's do a grep again and just grep for the deb images, so for the Debian packages, to see how many issues we have just on the underlying base image. And we have 798 vulnerabilities in this image without our application. So I guess we can do better, to be honest. And most of the stuff which is in here, we don't need at all, but it's there, so we have vulnerabilities in place. So let's bring in Wolfi. So we have another Docker file which is basically the same, except that we go for the latest Wolfi node image from ChainGuard. So they're providing base images. They're updating it nightly, so you can just rely on them. And this is what we do now. So we go for the ChainGuard node, and everything else is basically the same. And if we're now building that one, and run it, it's basically, the outcome is the same, the application will still work. The build is even faster because it's so small. You can now run it again. It's starting up, so everything is fine. So if we now check for vulnerability again, in best case, it's way less than those 700s here. So because we're talking about Wolfi, and we're getting SBOM out of the box, and at the moment we're just looking at the base image, not our application. So we can just use scribe again, and just referencing the container image from ChainGuard, and hitting enter, because there's SBOM in place. We're checking for vulnerabilities, parsing the image, takes some seconds. And we have no vulnerabilities found. So basically, same application running in a different base image based on Wolfi, 700 something less vulnerabilities in place, with just one change or one line changed. So pretty cool so far, but let's go a little bit deeper and have a look. As I said, we also have the ecosystem around Wolfi and are able to build reproducible container images and also declarative. So there are two tools we can use. First tool is Melange. Melange helps us to define our package we then would like to put into the container image, and then we have APICO, which helps us to build the actual Docker image. All of them are containerized, so they're basically just running a container. At the moment, they need to be privileged, linking the working directory to get the code, and starting basically with just generating some keys here. And then in the next steps, we are basically running Melange to build our package based on a YAML definition. So we can quickly check out the YAML here. And this is basically just the package name. We have the environment, so all of our dependencies, repositories, packages, and then, and the so-called pipeline where we're defining how to build, how to package our application. Then this is just the npm install and copying some files over. Then with this information, we can now go ahead and basically build our package. This will take some seconds. And the output of this, if we are done, is we will find the package here in Wolfi packages in this directory, though this is something I have built yesterday. So we're getting an APK containing just our application. And then we can basically, if this is done, we can go ahead and define our Docker image once again in a YAML. So this is basically the actual Docker file, but in a declarative way. It also starts with our contents and any packages we require. And then basically we say, hey, this is the path of the directory, this is the permission, this is our working directory, defining environment variables, defining the entry point, defining any kind of accounts. So we don't have any run commands here. So the long run commands and next line, next line, next line. It's really declarative here. And this is really, really nice. So can then, if the build finish, can go ahead and finally build our container image here. If the build finishes. Hello? Here we go. Okay, so basically we're now getting, as I said, everything in the packages here, so this is the newly built file. And next step would be to then run APICO, then providing, once again, the configuration, providing our YAML, and also providing the tag, how to tag the image to later use it, as well as where to store it. So basically, it's just a tar on the local machine in the first step. So let's run that one. And then we are basically now building our final image. With this, I would hand over to Phil to the next topic, and he will then use this image we're currently building in the next steps.
Thank you. Okay, where's the ring? Okay. Okay, now that we have a secure image, we want to run it anywhere on Kubernetes most of the time. And how do we verify that the image we are running is really the image that we want to be, that it claims to be? And also the ChainGuard guys are having a project called Sixdoor, where they are focusing on open source software, shifting left security, and you can basically, with Cosign, you can sign any artifact with a public key and in some ways. I will describe now. What the cool thing about Cosign, it integrates with policy engines like OPA, Gatekeeper on Kubernetes or Kaiverno, and you can really verify anything. Just a short word. The next slide is this. Yes, the demo. So we will deploy a policy into Kubernetes. We will use both modes for Cosign. So you can use the public mode, the keyless signing it's called, and the local mode where you can create locally a public key and a private key. So back to, oops, this is later. So this is finished, Cosign. So basically, we're doing first we are applying the policy, and we'll show, and then I will explain what's happening in the background. So we have a Kaiverno policy, which is enforced on pods, and every image which comes from the ChainGuard registry will be verified. We apply the subject, the issuer. The issuer is OIDC-based, and the URL for record. I will explain it in a few seconds. And this policy will verify or block any images which is not signed. So I will apply the policy.
You have to change the directory.
Yes, thanks. No, Cosign. Okay, my policy is now applied. Now I run just the nginx from ChainGuard, latest tag, and just assign a random ID. Oops. If I can use the copy command correctly. What you see now, so the pod is created, and what you see on the events, I don't have a lighter, but the first event on the top, you see that the pod default nginx 23775 passed the policy. So with the small policy, we just verified that the image is what it claims to be. But how does it work? This is the important thing. This is, like I said, the keyless signing mode. Basically, when you're on the left side, you're a developer, you authenticate with OpenID Connect. So at the moment, you have support for GitHub, Microsoft, and Google. I think GitLab support is coming. So it's OIDC. There's on the Falsio Certificate Authority, which is part of the Cosign. There's a in-memory private key and public key created. The Falsio Certificate Authority will authenticate with OpenID and verify the issuer. And then it publishes a signing certificate to Recore. And Recore is really the important thing here. It's also an open source project. You can install it locally, or you can use the public one from ChainGuard. And Recore stores the public certificate and verifies then the signing timestamp with the public key. And the private key, because Falsio creates a certificate, which is only 10 minutes valid, so the private key is completely destroyed. So the only thing is you have the public key on the right side, the publisher signing certificate, and in the transparency log, you will see the public key and then matches with the OIDC issuer together, matches and creates a valid entry in the record, so the image is verified against this. We can also show you this. As you maybe see here, we have a char of the image. Yeah, this is the hash, and it's the same like here. I just shortened the demo, and you can call recore with the recore CLI and just go against this log entry in the recore. It's public, and then you will see the verification of the public. Wait, I'll make it a little bit bigger. So wait. This is the entrance in the record log which proves the validation of our image. So here you see the image char, so the hash here, this one. And then you see all the commands, which is going with the image. And here you see the public key. And to get a record with the file show certification authority proves the validation of the image. So it's really what it claims to be. But if you want to use Cosign in the local environment, you can also use it locally with your own private and public key. So we have to load our, is it correct? Yes. We load our image here because we're using not Docker. So we will push our image to the registry. Take some seconds. Then we generate locally a public and a private key. We will sign the image, and then we will write again the policy which proves that this image is what it claims to be. So here I just use CDS. CDS here doesn't matter. Yes. So what we get here now is the Cosign key and the pub key. And with this, we take the pub key, copy it to our policy. Oh no. This is the same policy, a little bit different. So it applies to every kind of pod from this image registry. It's from Nico, and we will say the public key of the image must be matched this key. Okay, then we apply the policy. Sorry, I need to sign for sure before I can apply the policy. And what it does, it stores this the signing information next to our image in the GitHub registry. Then I will apply my policy again. This we don't need here. Then I will create the Hello app from Nico, which you built with Wolfi. And everything is good. The pod is created. And we can see here now, again, where is it?
Down.
Was it down? Yeah. It's too tricky here. But where is it? Here. You see that the policy again passed. So we have now very verified that our image is what it claims to be. Okay. Then Nico needs some time. 10 minutes. I'm good. So the next thing is now we have secure image. We verified the image is what it claims to be. But what is with runtime security? So process exited in containers during runtime. So here we have a cool tool called Tetragon. It's an eBPF-based security observability and runtime enforcement. It's from the guys Isovalent, so it comes with Serum together. What does Tetragon does? It gives you awareness in your cluster, what's happening. For example, a pod spawns a shell or a file is opened. And the cool thing about Tetragon, it's by default Kubernetes aware. So you can, Tetragon understands pods, namespaces, labels, so you can really work with that and build your policies. And through to the eBPF stuff, you have really real-time enforcement. And how does Tetragon leverage eBPF? I don't think we have to talk much about eBPF because if not, you can come later to us. But basically, Tetragon sits in user space. It's a daemon set. It hooks into the kernel and grabs the system calls which are happening. For example, if you open a file, a system call is invoked, and Tetragon in real time can hook into this call, get information out of it, like pod namespace, what I said, and can act on this. You can like make an output, you can kill the process, you can send an event, integrate with observability logging tools, and basically this is what Tetragon do on a small node. And then I will get back to Nico for the next demo.
So what we'll do now is trying to get into a cluster or a container with the log4shell. Security vulnerability, yeah, it's a bit old, but you still see it in the real world. And it's easy to show, and we're really seeing that we're into getting access into the cluster or into the pod. So it's a nice demo. And then after showing that it works, we're trying to prevent it with a Tetragon policy, a pretty easy one. So Let's clean this up quickly. Okay. So, or maybe getting one more slide. How does Log4Shell work? So basically, the idea is to provide or to use a malicious ChainDI string. This ChainDI string then gets logged by the Log4j logger. The Log4j logger parses the ChainDI string, which contains an LDAP server URL. Then basically the process calls the LDAP server, and the LDAP server says, hey, you will find on this HTTP server a Java class, please download it and load it. And this Java class then basically allows us to spin up a shell into the pod. So this is basically what Log4Shell does. To do so, we need to spin up an LDAP server, we need to spin up an HTTP server, and we need to make sure that basically the baseline is up and running. And for this, I have just a Linux machine. So it's just a virtual machine with a public IP running thumb there. And the idea is here to spin up the LDAP server and the HTTP server, and this is nothing I provided, so it's an open source POC of Log4Shell. The link is also included in the repo, you can do it on your own. It relies on Python to spin up the LDAP and the HTTP server, so it takes some seconds. So now the LDAP is up and the HTTP server is up. And then we also need basically an open port to connect to. So it's a reverse shell. So basically, the pod will connect to an open port on this virtual machine. So we need someone to open up a port. So let's go for a netcard. It doesn't matter which port it is, but I thought 443. If a port is open to the internet, I guess it's that one. So the next thing is that we need the ChainDI string. This is that here. So it's basically says, let's do LDAP to the virtual machine on the LDAP port. And we also need a vulnerable application. There's that one here. So in the username, we are just using the ChainDI, and as password, we are just going for blah. Doesn't matter at all. So and if I now hit enter, it's loading, loading, loading. Nothing is happening here. But if I go back, we're getting a connection received here. And if I now do an ls, we're getting a file system. And this is the file system of the pod running in our Kubernetes cluster where the application is running. So we're now in the pod and can do anything. So we will not go further here, but basically, we can now end up getting this is Azure, the underlying identity of the Kubernetes cluster running in Azure, using this identity to spin up a virtual machine and mine some bitcoins or something. So from here, it's really easy to go further if there aren't any further security issues here. So now let's see how we can fix that one quickly. So basically, with Tetragon, as said, we just need to apply a policy, and this is a really, really easy one. So we have a kind tracing policy, which comes with Tetragon, and then we can define specific settings. So like, hey, if something is executed and it's not a PID 1, for example, do something, and do something in this case would be just kill. So we're going here really with an easy example, but basically, we're defining if there's a second process in a container, which shouldn't be the case if you're doing container the right way, just kill it. Of course, you can make it nicer, but let's stay with a simple example here. So if there's a second process and a reverse shell is a second process, let's kill it. But this is what we're doing now. So applying the policy.
You're on a VM.
Oh. Makes sense. Let's apply the policy here. And it works. So now we have the policy in place. So let's try it again. Going back to the virtual machine. LDAP and HTTP server are still running, so we're just spinning up again the open pod. Copying again the ChainDI string. Going back to our application, which is now timed out. Putting in the username. Now we're going for blah blah. Logging in again. It's not loading. We're getting an error. Password was entered is invalid. But now if we go back, we're getting a connection received, doing the ls again, but it doesn't work. So yeah, we open up the connection, but basically in the same time, the browser got killed in the pod. So yeah, there were some milliseconds we had access, maybe, but basically we can't get any further from here. And if we now go back and check the logs, there's basically the Tetragon container running in the cluster and the kube system namespace has a specific container just to output the logs, and then you can pipe that into the Tetragon CLI called Tetra to get another view. And we now open up that one. We're seeing all the processes running on our container. We're also seeing here the Java running up a sys executive and that being killed afterwards. And this is exactly what our policy did. So basically killing the reverse shell we just opened up. Yeah, and with this we are at the end. If you have any questions, I guess we have time for questions now. The whole slides and demo are available on GitHub, so you can try it on your own. Don't miss to destroy your cluster after testing it, because it's not only open to you, it's open to everyone. Yeah, and then we have time for questions.
Yeah, thank you, Nico, Philip. We do have a few questions. So we'll go through as many as possible, and then I, as always, suggest you catch Nico and Philip on the floor. Do Wolfi Melange support easy creation of multi-arch images?
I'm not sure. They were thinking about it. I'm not totally sure if it's already implemented, but I guess if not, it's on the way. But I have to check.
I think Wolfi does support multiple images. I'm not sure.
Yeah, they talked about it, but I'm not sure if it's already implemented, but at least it should be there pretty soon.
So, are you aware of work being done to remove the need for privileged containers in the Melange AppCo build, thinking about CI pipelines?
Yeah, there's also an open issue. I would have to check the the settings. I'm not sure, but they're aware of it, and they are security companies. So I'm pretty sure if there's possible, they will work around it. On the other hand, of course, it's nice to run it in a container, but you can also just go with the binary and build it in your CI/CD. Then you can get around those privileged containers. But I think at the moment it's still required.
Cool. Who stores the Cosign log? How can you ensure its integrity?
The Cosign log, so it's a record. This is a public instance from ChainGuard. So the integrity is by ChainGuard, and doing the because the private key, is created just in time for 10 minutes, and then afterward the private key is deleted. Yeah? And then with the public key and together with the OIDC, while creation with a certificate, which is 10 minutes valid, so this is the integrity. So you just need the public key, the rest is integer.
But you can also host your own instance.
Yes, you can also host your own Rego and your own Falcho CA.
Cool. Is there a way to revoke a signature with Cosign, i.e. if Azure loses their signature key?
It's the same, somehow the same, because the signature, the OIDC token is only valid by creation of the signature. It doesn't matter afterwards, because then it's destroyed. It's just a short-living thing, which is needed for creation, and then the public key is an important thing.
Fair enough. I'll do one more. Do you want to pick one which you can see?
Maybe go with the other default policies for Tetragon, because this has 2 thumbs up.
I think they're working on it. So they have an enterprise version also, where you have a little bit more features. In the open source version, what we showed, you have to write your own policies for now.
Yeah, there are some samples and documentations, but enterprise provides you with some defaults and also a higher abstraction that you don't need the syscall. You're basically justifying what you don't like to have, and they knowing what syscall it is. But in open source, it's a little bit of work at the moment.
Cool.
Does Tetragon run on Node cluster privilege?
Do you want to do another one?
Yes. Yes.
Which one did you go for?
The first one. Does Tetragon run on the Node? Oh, it's
the second one.
No.
So,
Yeah, but
does Tetragon run on the node or in cluster? Does Tetragon, as a high-privileged tool, add a new attack vector? This is the last question we're going to do, and then...
Tetragon is a daemon set. It runs on every node because it ejects the eBPF program into the kernel. And it is an attack vector, yes, but for runtime security with the kernel, you need privileges. So you also have an attack vector when you don't run Tetragon because you don't see any syscalls happening from containers.
So yeah, basically we have to go the way.
Yes.
Otherwise it won't work on the technical basis. But yeah, it's an attack vector, of course.
Yes.
Cool.
Okay.
Thank you, gents. Round of applause for Nico and Philip. You wanted to say?
Just the important thing, we have stickers.